Backwards, though. So like I said, a lot of people could give this talk. I got picked to do it, and I'm grateful for that. All right. I realize that probably nobody can read that, and that's okay. What I've done with this talk is I put everything on here, and it will go online, and you'll be able to see this sort of thing in one page. I'm going to cover every one of those columns separately, so you'll see it in a bigger format. The point is, I've looked at 6 decades of lake management and 6 different areas, limnology, which is the science of freshwater oceanography, if you will, monitoring technology, the conduct of monitoring, institutions and programs, management focus, and economics, all of which are central. If you're not familiar, another analogy I've used a lot, lake management, really all of environmental management is a 3-legged stool. Science, economics, and institutions or sociopolitics. If all 3 legs aren't solid, the stool falls over. The science we always get better at, but we know a lot. The economics, everybody can understand. I can tell you what it costs. You can tell me if you can afford it. The institutional part, the sociopolitics, are the hardest thing in lake management. And that's what a lot of your lake associations, New Hampshire lakes, groups like that are all about. All right, so the first one, limnology. Again, this is the technical side, but it's the basis for lake management. Most of you get pounded about phosphorus all the time. We didn't know about that in the 50s and 60s. There's always somebody. I might add that these are the decade where this thing really became a real issue. There was always somebody way ahead, 30, 40 years before, who brought it up and got laughed at. But when it became mainstream, it was really the 70s. The relationship between phosphorus and chlorophyll, clarity, all those sorts of things, those relationships are late 60s, early 70s. Watershed land use connection. Again, there's an old paper about the lake as a mesocosm, which some people claim set lake management back 100 years because the guy basically said the important things to lake end at the shoreline. This is dead wrong. But those things happen, and that's a published peer-reviewed paper, I might add. Now, it's from early 1900s, but hey, you got it wrong. Nitrogen phosphorus synergy. I mean, we do push phosphorus, and it is the key element, but there's a lot of other things that matter out there. Nitrogen certainly is a factor, various micronutrients, the alkalinity of the water, the pH, all those things figure into it. So it's a complete package that you have to understand. And that really came in the 90s, the complete suite of things. In the 2000s, we kind of learned the limits to watershed management. What can you do? You cannot take a parcel of land, turn it into an urban or agricultural use, and expect that with best management practices, you can make it behave like it was forest. That's a fallacy. Usually when you change the land use, it changes, the contaminant loading goes up by a factor of 10. And the best management practices cut that in half. So you're still looking at a 5-fold increase. Now you can slosh it either way a little bit, but you cannot have a developed watershed and not expect water quality problems. It's not realistic. And we didn't understand that as a government for a while, and I'll come back to that. In the 2010s, we got more into internal loading. I mentioned some people get it. Famous limnologist by the name of Clifford Mortimer in Wisconsin wrote papers about this in the 1940s. But it took till the 2000s for us to really grasp the importance of internal loading of phosphorus, the stuff coming back out of the sediment and being recycled. And then we eventually had more on the ecology of cyanobacteria, blue-green algae. Interestingly enough, it's a cadre of female limnologists from New England that figured all this out. Caitlin Carey was an undergrad at Dartmouth, Holly Ewing over in Maine, Kathy Cottingham at Dartmouth, a few others who worked this stuff out and figured out that the blue-greens, for the most part, are growing on the bottom, sucking up phosphorus right at the sediment-water interface. Then they create gas pockets in the cells and float up to cause blooms. That's why some of your seemingly really clean lakes wind up with blooms. They're not getting into the water column. In fact, the blooms only last a week or two because they've got nothing to survive with. It's like packing a picnic lunch going to the top of the mountain. You got to come back for dinner because it's not going to be enough to hold you. But we didn't understand that until Kaylin's actually undergraduate work, and she was a class of 06 because she was a friend of my son's. So, we didn't know this stuff. Sharp increase in the use of eDNA, particularly for things like zebra mussels or invasive species of plants that are hard to find when there's just a couple out there, but you can now find them with genetic technology. It's amazing stuff. The Secchi disc in the upper right there is still kind of one of the primary tools and probably will stay that way. It's a phenomenal tool for virtually no cost, all the way down to eDNA used for something like zebra mussels on the lower left. In between, we figured out, more phosphorus means more chlorophyll. It also means more cyanobacteria. That's the diagram there. It's not a pretty one, but more phosphorus means more cyanobacteria. It's just an empirical relationship from thousands of samples. More rain, more phosphorus loading. Climate change has a function. And climate change, just the last 60 years, look at Winnipesaukee ice out dates, you can see the decline. There's lots of noise in the data, but there's a real trend there. It's real. You can debate the causes of climate change. You cannot claim it doesn't happen. It's always happened. It's just particularly vicious right now. All right, monitoring technology. This is probably the biggest single change, which I hadn't really thought about until I was preparing for this talk. How many people in this room have ever done the Winkler method? Yeah, so it's not many. You either did it at a class or you're as old as I am, because when I was an intern for New Jersey DEP, that's how we did it. You basically have to get a water sample from any location and depth in the lake where you want an oxygen. You put chemicals in it, you stopper it with no headspace, and you take it back to the lab and titrate it. And people are going, what? Yeah, you can have hundreds of samples to get a bunch of profiles. By the time I was a full-fledged employee in 1977, we had meters. Now, they were a dial that went back and fluctuated a bunch, but okay, you got the general idea. Now, like lower right picture there, you've got a bunch of probes on the head of a sonde that you stick down at any depth you want, and maybe you even leave it out there and the phone sends you the data. It's amazing what we've come to. So initially, it was a lot of lab measures and field observations, switching to more and more measurements being made remotely in the field, to the point where you didn't have to go in the field. The instrument's out there telling you what's going on, to adding GPS, satellite monitoring, various automated field measurements with telemetry, lots more mapping capability, and entire platforms for the entry of data and the use of drones and everything else. It is amazing how far we've come. And it's not that expensive. It's not cheap, but it's not that expensive to do the job well. Okay, monitoring conduct. This has one major shift over time that I hope everybody here can appreciate. When I started in the 1970s, it was all professional monitoring. Volunteer monitoring was untrusted and unfunded. You could not get a dime of federal support for using volunteers. Who's the biggest supporter now? It's amazing. There was some in the 80s. It really took off in the 90s, particularly here. I mean, actually, I think UNH was late 70s, right? Yeah, but you guys were on the forefront of this. Now you have whole networks. There's an entire conference that Jeff's helped set up for a number of years where they get all the monitors together from all over the country to talk about stuff. The volunteer monitoring has become the key source for data. And it's really the most essential source in many cases, because if you're looking for invasive species, how many people here get paid regularly to go do lake work are here? Yeah, a smattering. Okay, suppose we're now responsible for finding any invasive species in New Hampshire. It's not going to happen. You need the volunteers. It's the only way it happens, and I'll come back to that. So we've had a major, major shift in how we do monitoring. Okay, institutions and programs. This may get a little more controversial, but just to stick to the facts, the Clean Water Act got enacted in the early 1970s. The US EPA then spent most of a decade developing a lakes program, which actually came out in 1980. Parallel to that, the states were developing programs, and everybody started getting into monitoring lakes and trying to sort out what we might do with them. The 80s, we added the Section 319, with part of the amendments, and that's non-point sources. So Section 314 is clean lakes. 319 is non-point sources for watersheds, which seems like they should synergistically go very well together, but they never did. It was a constant fight for who gets the money. And 314 was viewed as in-lake work. 319 was viewed as watershed work. And there was a shift over time as we discovered how important watersheds were. The pendulum swung too far. Now it's, and you can find this in federal government documents and even some state ones, I don't know about New Hampshire, you can solve all lake problems by working in the watershed. Absolutely false. You can't do a thing about invasive species in the watershed, and you're not going to get rid of most cyanobacterial blooms if you don't deal with the in-lake, and I'll come back to that. So we lost the federal support for the Clean Lakes program. We haven't had money in that program since 1996. So there isn't a federal source of those dollars, which meant that now the states had to step up and deal with it. Some did, some didn't. Here in New Hampshire, you guys done a pretty good job. I'm in Massachusetts. We've done a dismal job. That'll come up again. Actually, no, here's right here. Best example I can give you is invasive species management. That little diagram there, the table with all the yeses and nos and such. If you look at all the elements, I did this for the Northeast Aquatic Plant Management Society this past winter. I looked at 9 programs, 9 state programs to see how we were doing, because I was so upset with the way things were being done in Massachusetts. Is everybody like this? And the answer was no, we were the worst. Maybe tied with Connecticut. And there's 2 wealthy, progressive states that cannot manage their way out of a paper bag when it comes to invasive species. They're adversarial. You can't get a permit to do anything. If I go in to get a permit to deal with the Eurasian water mofo, it's the exact same process if I want to put a Walmart in a wetland. It's the exact same process. There's no streamlining, there's no speed, of course you need to do this. No, it's not. It's assumed that you're messing with the lake here, we're going to put you through the ringer before we give you a chance to fix it. And if you don't respond rapidly, meaning weeks to a few months, you've missed your boat. So when I look at these, New Hampshire's doing pretty well. The best is actually Maine. Maine actually has a law that, well, all the states have a law that says you can't bring in an invasive species. But only Maine has a law that says, and if it shows up, we are the state responsible for doing something about it. New Hampshire is second with the law that says we probably should do something. It doesn't make you do it, but they recognize you should. Massachusetts, not only do we have such a law, like I said, they will fight you tooth and nail if you're possibly going to impact any interest of the Wetland Protection Act or an endangered species. There's no acknowledgement that, hey, if I do scorched earth in this 1 acre parcel, I save 700 acres of lake. They don't think that way. So there's a real problem there with our institutions and programs. And the late Lowell Klessig, one of the founders of NULMS, used to give a talk on sustainability and everything else. And he used to show a picture of too little freedom. And back when he was doing this, it was the flag of Iran. And they'd do too much freedom, he'd show the US flag. You know, we don't jump on these things. Our programs are not geared to do what we need. They're not geared to solve problems. And I'll mention that at the end. So with limited federal direction, all the state programs had to kind of go in their own directions. You guys are fortunate. I'll show you a couple slides about New Hampshire. You've done well. You really have. It doesn't mean your lakes are all doing well, but the programs have done pretty well here. There's an ongoing local focus. It's really shifted to that. Lake associations are more important than ever. And again, in comparison, we're all here for New Hampshire lakes. There is no longer a state lakes association for Massachusetts. It doesn't exist. So this is the kind of stuff we're dealing with. With all this, we've put out a lot of paper, some of it really good. Over in New York, you got Diet for a Small Lake, which gives you some really good tips on management. I have one out, well, not out yet, Massachusetts Guide to Algae and Aquatic Plant Management. It's just completed its public review at the end of May. It'll probably see the internet maybe by the end of the year. They're starting to deal with the comments and such, but it's field season and they only have so many people. It's really helpful. It's rather Massachusetts-centric in that the agencies infuse so much regulatory stuff into it, sometimes lose focus, but the technical stuff is useful to anybody. The point is, you could get buried in paper, like the lower left slide. And what I want you to remember is, paper doesn't clean up lakes, people do. Even programs don't clean up lakes, people do. And there's an old business axiom, at the end of the day, you bet on people, not programs. So you guys are important as individuals, and what you do here matters. Okay, management focus kind of goes with the institutions. In the 70s, it was all about in-lake stuff, all about it. We had not no knowledge, but minimal knowledge of watershed stuff. We just didn't pay that much attention to it. In the 80s, we discovered it. The pendulum swung way too far towards the watershed, but we realized that there are watershed issues for sure, that they drive most things. Then the in-lake stuff takes off from there. The 90s were very much focused on watershed management. The in-lake efforts tend to get downplayed, although again, not everywhere. The potential need for both came back to us in the 2000s, and it's come back to be more balanced since. The original way I wanted to write those last 3 was, maybe we need both. And the second, yeah, we probably do need both. And now it's, of course we need both. You know, it's the old beer commercial, less filling tastes great. You know, it's both. You've got to have both, and you need to know where you are in the continuum. So we went from the top row of slides, all in-lake, to the lower left, which is all watershed, to hopefully seeking some balance. And that last picture in the lower right with the people in the boat full of water is to remind me to give you what I think is my best analogy I've created ever. It's how to understand the continuum between in-lake problems and watershed problems. Think of it like a leaky boat. If you've got a leak in your boat, the boat's going to fill with water and it's not going to be useful. If you've got some kind of magic epoxy you can stick down and through the water and smear it on the hull and you no longer have a leak, your boat's still full of water. It's still useless. You have to deal with the in-lake aspects and the watershed aspects. Now, if your boat has the tiniest leak, a loose rivet, and it's going to take 3 days for your ankles to get wet, yeah, I can bail out a few things in the morning and go fishing all day, and it's no big deal. If, on the other hand, I've got a huge gash in the hull, so that no matter how fast I bail out, the water's replaced, there's no sense in doing the in-lake stuff until you've taken care of the watershed. And every lake is different. You need to know where you are on that continuum. What happens in one is going to be very different than what happens in the other. I have 2 lakes I've worked on that are side by side. The one is like almost an appendix to the other, but it only gets affected by a small watershed and any backflow from the bigger lake. The bigger lake has a huge watershed with sewage treatment plants in it. It's a mess. Those 2 lakes are night and day different in terms of what they are and how they have to be managed. But and they're right next to each other. Why would they be different? They are. So you have to understand that stuff. All right, finally, economics. You know, this is better given by a resource economist, but the real simple version there is when we started out, there were huge bags of federal money being given out. It was amazing. A guy who was the Clean Lakes coordinator for Connecticut, Chuck Lee, once said to me, "Do you realize how lucky you are that you came into this as a career when they were just doling out money left and right for lake projects?" And he's right. He said people that start now have to scrap and everything else to get any kind of thing, and you can't do anything experimental. If it fails, you're out. He said it was amazing what we had. And then as the feds dropped out, not completely, we still had 319 money. There was still some money getting spent on lakes, although it wasn't technically through 314, that section. The states had to kick in, and again, it varied in places, but most states put some money up to try to do things. And now with economic pressures being what they are, they've both sort of toned down. There's not no money, but it's moved to the local level. So more and more it's being funded locally, and that's not necessarily a bad thing. I'll come back to that as well. So we got a mix of it, and there are certainly barriers, but you need some creative funding mechanisms. All right, a few additional historical influences. There's federal nationwide surveys. There was the National Eutrophication Survey in the 1970s. There was EMAP, or Environmental Monitoring and Assessment Program, in the 1980s. And we had the National Lake Assessment starting in 2007, and they're through like 4 cycles. It's every 5 years. And those are helpful. They're not going to tell you about your lake personally. They may not even tell you about the trend for your state lakes because there's only like 1,000 lakes involved across the country. But states can choose to beef it up or do more with it. And then we had the Secchi Dip-In, which was the late Bob Carlson, and NALMS actually runs that program now, North American Lake Management Society. And all these things had some politics and technical squabbling, but they all pretty much show the same thing. Our lakes have been in decline for many years. Oh, you can spin it and make it look like one improvement's happening here or there or whatever, but the bottom line is things are not getting better. Well, reality is that's natural. Lakes age and die. Well, die is really, they get more productive. They age and they live even better, but they get productive and turn into wetlands. But that's an eons type scale, whereas people can turn that into a decade or less. But generally speaking, there's more people, more development, more farmland. We wind up with a worse set of conditions in our lakes, and it's harder to manage for, so you have to constantly be at it. Also, we had economic studies of lakes, and these have been spread out over the last 20, 30 years, but they're fascinating. They all kind of point to the same thing when I went through them. There's a documented loss of property value and tax base with eutrophication, cyanobacteria blooms, and invasive plant species. And the numbers, if you got to hang your hat on something, somewhere between 2 and 8%. Now, that's not a big number, although think about what your house on a lake is worth now after the pandemic. It's a big chunk of change. That's a lot of money that could be lost. The house doesn't become useless. I know people that will still spend a ridiculous amount of money on a house or on a place that's got blooms or full of milfoil, but you do lose some value, and it does affect the tax base, which then affects the whole community. The economic gain from management almost always outweighs the cost. often by more than 3 to 1. Again, if you think of it, the loss is 2 to 8%. You might have to spend 2% to protect it. That's dead even up to 4-fold benefit. The barriers to action include high initial costs. If you got to do something, you can't often do it incrementally. You've got to do it in one burst or a couple shorter bursts, and it's expensive. And the cost of prevention is much lower than the cost of rehabilitation. 30 years ago, I wanted to write a paper called The Ounce of Prevention. I could not find enough data that could give me a direct comparison between what it costs to fix a problem versus what it costs to prevent it. I think that exists now. I'm going to put that on my retirement list, things that I got to do, because that's worth looking at. And I know it's true. It's just, I can't prove it to you with solid references because nobody's written that paper yet. But if you think about it, if you want to get creative, and they do this in Maine, I like it a lot, they tell people who own homes on lakes, you should be prepared to commit 2% of your property value to the protection and management of that lake. That's not a small sum of money. But again, you could lose 2 to 8% of your value if things go wrong. Now, it's great if you say, well, I'll just trust nothing will go wrong or my neighbor will cover it and I'll just keep my money and keep my house. But you got to be part of the solution. And that's where it's all come back to roost locally. And it's worked really well for them in Maine, and they've gotten great results. All right, quick timeline of New Hampshire. Didn't want to make this just about the national perspective. I got help from Amy Segula. Actually, Andrea provided me some information too. Not a whole lot going on from the 40s through the 80s. It's certainly accelerating, but mostly studies, organizational, creating structures to do things with lakes. Not a lot of real management. There was some, for sure. Keyser Lake got an aluminum treatment back then. Some other things have been done. But this is a study time, and an awakening time more than an active management time. Since then, with the 1990s, just going crazy. Great guns here. You got New Hampshire Lakes formed. You've got the Shoreland Protection Program. You got the Lake Management Protection Program. You got a Lake Management Advisory Committee, all in the 90s. We got the DES Biological Section. Dave Niels, who's not running that anymore, is here today as well. And they've done a lot of great stuff that goes back to Jody Connor, if you remember Jody. Enhancements to the state water quality standards and anti-degradation provisions in the 2010s. You got the cyanobacterial program forming, the Lake Mapper application, which is really helpful. I use that myself. And then creating statewide cyanobacterial mitigation plan, and a lot of other things to try to balance watershed and in-lake management. Understanding the relationship between watershed drivers and in-lake drivers, where a lake is on the continuum, and what buttons need to be pushed to get the conditions we want. A lot of action in New Hampshire in the last 40 years. All right, so what are the problems faced by lakes? There's nothing new here, folks. Okay, we got some new contaminants, PFAS, things like that. But in terms of the things really threatening lakes, it's all the same things we've had since any of us were born. It's not new, it's not different. So the question is, have we learned anything to do a better job managing? The leading cause of water quality impairments in New Hampshire is a split between stormwater, which accounts for 50% of the impairments, and internal loading of phosphorus, which there's not a percentage. It's not necessarily the other 50%, something smaller. And it hasn't been thoroughly studied in New Hampshire yet, but you've got things. Amy Segula is off doing a phosphorus inactivation program today. So this is an active area. Again, that's bailing the boat out. If the leaks are small, you can bail the boat out and still make it useful. You probably still need to patch the leaks, but you could at least regain the function of your lake for some time, and then you have to, again, figure out how much time that's going to be. Okay, how have the available management techniques changed? And the answer is yes. There's a whole lot that's new that we didn't do before. The first consulting job I had, the supervisors, the guys that ran it said, there's really nothing new in lake management, it's just how we use it. And that is just dead wrong again. All sorts of new stuff has come out. We have new products, different types of herbicide, different types of benthic barriers, phosphorus inactivators, bacterial products, which are tough because they're not they don't really tell you what's in it or how it's worked, and they're not even approved as algicides or whatever, so there's some difficulties there. Again, there's a lot of technical stuff to know. And watershed pollutant trapping. A lot of things have been done. The whole rain garden thing is only 20 or 30 years old. Major advances in oxygenation and how we do it, in phosphorus inactivation, and how we use herbicides. They're all tools. It's fine not to like a tool. A lot of people don't like herbicides. Some people don't like drawdowns. Some people don't like dredging. It's fine not to like it, but you're not in a good scientific standing because they're all tools in the box. Is there anybody here who never hit their hand with a hammer? Did you then throw away the hammer and put in nails with a wrench? Of course not. You learn how to use the tool better. So don't go around bad-mouthing tools. You can prefer something else, but nothing needs to be thrown away. They all have value. We have learned the limits of watershed management techniques. Again, if your watershed is more than 30% agricultural or developed land, you're going to have water quality problems. You cannot get around that no matter how many BMPs you put in. You can minimize it, and there's lots of creative ways to do it, and you should. Things like the Lake Smart program are brilliant. But you're not going to totally prevent it. That house, that driveway, that road are all going to have an impact. And if you want to have those things, there's going to be impacts, and you got to deal with them. The value of prevention has been hammered home time and time again. Source controls, boat inspections, again, the Lake Host program, all these things, critical elements of managing our lakes. Okay, do we better understand the key processes? Absolutely. I mean, I laugh. I look at this list: climate change, land use impacts, internal loading, cyanobacteria ecology, invasion ecology, particularly hybridization of plants. We didn't know anything about this stuff 50 years ago. Next to nothing. The word climate change was never brought up. Land use impacts, maybe a little, but we couldn't quantify it. Internal loading, I look at my reports from the early 1990s and it's not mentioned. Cyanobacteria ecology, I'm a phycologist. I study algae. That's my first love, what I learned to do in college with Hannah Crosdale at Dartmouth. And I didn't understand cyanobacteria ecology until these ladies from New England figured it out. And there's other stuff too, other people working on it as well. But this is stuff we didn't know. So we do know a lot more now, and somebody who understands this is worth it to you to get to know and understand what they know. A lot going on. So, okay, what does the past tell us about how to manage in the future? Okay, number one, monitoring is essential. We have the tools to do it well. It does not take a boatload of professionals, and we can get the data we need to understand. First and foremost, where are you on that continuum from watershed problems to in-lake problems? You know, how important is internal loading? How important is the loading for watershed? Bear in mind that the internal load is a product of old watershed loads, so there's still a link there. But you're on a continuum that is unique to your lake, and you need to know where you are. Spend the money on getting the needed data. Support the organizations that collect the useful data and become a volunteer monitor. You'll learn a lot more. Okay, watershed management may protect a lake, but in-lake management is necessary to rehabilitate. Not 100% true all the time, but pretty darn close. The point is, watershed management is mostly lake protection. In-lake stuff is mostly lake rehabilitation. You need both. So it's really a question of what percentage of the effort has to go into each. And again, it's going to be lake specific. You can't look at the lake the next town over. Well, this is what they did. It should be fine for us. No. You've got to understand it for your lake. If you have significant inputs from urban or agricultural land, they're going to be hard to control. It is not easy. Can be done to a reasonable degree, but you're not going to completely eliminate it unless you eliminate the land use. And we all got to eat. Invasive species are an in-lake problem. A lot of cyanobacterial blooms are an in-lake problem. You cannot fix those with watershed management. That's the fallacy in a lot of the federal government edicts about just working in the watershed. Now, I've seen others that Maine is big on this. I'm not sure about New Hampshire, some extent in Massachusetts. They want to see the effort in the watershed before they will support the in-lake management. That's basically saying patch the leaks in the boat before you bail it out. Generally sound advice, but if the leaks are really tiny, bailing it out would get your lake back to a functional state before you have to spend the money on fixing the leaks, which could be pretty darn expensive. So again, where are you on that continuum? You need to know. Okay, public funding is likely to be very limited. Do not expect someone else to fix your lake. If you're on a big public lake, I think you have a right to expect public dollars to support the management of the lake and so on. You know, in Massachusetts, a great pond, anything bigger than 10 acres in its natural size is technically owned by the Commonwealth. They accept not one iota responsibility for managing it. Drives me nuts. But I get it. Local stuff is where it's going to come from. Economics favors lake management, but there are barriers. You need to think in terms of protecting and enhancing property value. Simple economics, everybody gets that. And you get what you pay for. There's no magic bullet. I wish I had that proverbial nickel for everything. Hey, I just saw on the internet this magic thing. Yeah, right. You know, I tell people I charge double for having to debunk stuff they read on the internet. You know, it's inevitable. There are a set of tried and true things, and there's a whole lot of other experimental things. Again, I don't throw away any technique. Everything may have value, but you cannot just leap to something that you saw. I mean, any doctors out there, would you take surgical advice from the internet? You know, stock tips, you know, whatever. You got to think that through. All right, the ounce of prevention really is worth the pound of cure. Avoid problems for lower overall cost and better lake conditions. Use early detection and rapid response to deal with invasive species. If you're on a lake, you should be volunteer monitoring, learning the invasive species, and when you go out on the boat, just look around for stuff. Everybody should be doing that. That should be a complete, everybody in the lake's a volunteer monitoring for that sort of thing, because the quicker you find this stuff, the easier it is to deal with it, and it costs way less. Manage the watershed to limit the inputs. You know, okay, we're not going to make it. I was once asked very early in my career at a lake association meeting, if there's one thing we could do for our lake, what would it be? I said, move out of the watershed. And they said, all right, if there were two things, what could I do? You know, all right, you're not going to get everybody out of there. It's not going to go back to forested, but you can manage what's there. Get it to be unconnected as much as possible. You know what? Storm drains are running right into the nearest stream that goes into the lake. You know, manage the stormwater, manage the runoff. And you've got to sample during wet weather. You can't do this from dry weather sampling, which is miserable, but there's automated things that'll do that now. I have real simple passive stormwater devices that you can put out that are cheap, 50 cents a piece. You know, there's no excuse for not having good stormwater data. And then evaluate the internal loading and monitor cyanobacteria to allow a prompt response. Internal loading can be explained with a few sediment samples and a moderately expensive $500 to $1,000 lab testing, but you will know what's going on. And then with oxygen monitoring, you'll know what area is potentially affected. It is not hard to estimate internal loading for a lake. And probably the most controversial one here. Regulatory agencies are set up to avoid harm, not solve problems. Now, I said regulatory agencies, not environmental agencies. DES has both within it. Lots of places do. In Massachusetts, we have a DEP, which is almost entirely regulatory. Department of Conservation and Recreation are the ones who actually manage lakes. It used to be it was all in DEP, and some reason they thought it was a conflict of interest, so they put the people that manage in one place and the people that give permits in the other, and they never talk. You've got a little better here, but there's still frustrations in that regard. Agencies that give or deny permits can protect a lake. They're not going to repair it. Remember I just said, once the stuff's in, the boat's full of water, they'll help you with patching the leak, but they're not going to help you bail it out. Now, that's not true. A lake program that's actually going to help fund, you know, phosphorus inactivation or dredging or something else, that's fine. But again, the regulatory aspect is geared towards preventing harm, not repairing existing harm. So you need to get involved with your lake. Local champions initiate action and they sustain excellence in management. Get involved at the local and state level to promote sound management. Resist the politics of rehabilitation over prevention. That's kind of the flip of what I was saying, but okay, best analogies. I didn't ever really grow up, but I lived in New Jersey in my earlier years, and I was told, you know, point blank, working for the state, to be safe, move slow. To be really safe, don't move at all, just appear to move. And we knew politicians who would get us money to fix a lake, and they were heroes. But a politician who got money to prevent something from happening in the watershed was obstructionist, against progress, likely to get voted out the next time around. So protecting your watershed is not popular. It doesn't have great appeal, but you have to do it. You know, it's the old, you know, I walk around snapping my fingers to keep tigers away. It works, you don't see any tigers, right? You say, that's nonsense. Well, you got to do the things in the watershed that may seem like you're snapping your fingers to keep the tigers away, but it really does keep them away. And that's hard to sell to people. That's what groups like New Hampshire Lakes have been preaching for years. The volunteer monitoring programs understand this. You have to push your politicians that way, so you need to vote for people and programs that help lakes. And that is it. Yeah, I more or less made it on time, but I didn't give you a lot of time for questions or comments. If you want to take some, it's fine, but I'm going to stay around. Happy to talk to anybody at any point.